So today we're looking at an oscilloscope, and I've got a scientist with me to help explain what this thing does. Over to you, Professor Kent.
Hello. So yes, this is called an oscilloscope, and this machine plots in a graph. You're used to graphs, aren't you? From in school, you do graphs. This is an electrical signal, and this is how it changes with time.
Hold on, I thought I was seeing sound waves.
Ah, well, you cannot see sound waves. You can hear sound waves, can't see them. So what we have to do is we have to turn those sound waves into an electrical signal, and then you can see that on the oscilloscope.
Is this what sound waves look like then?
Well, yes, in a way. And what we can do is we can now turn on the loudspeaker, so you can now see them as well as hear them.
Okay, do sound waves change?
Yes, you can change the volume. And you can change the pitch.
So let's look at volume first. What happens to the sound wave when volume changes?
When the volume is low, the sound wave is very weak, as you can see here on the oscilloscope. If we turn the volume up, you can see the wave is getting stronger. And of course I have to speak louder so that you can still hear me.
So now we're going to look at pitch, which is how high or low a sound is. What happens to the waves then?
Okay, so all waves have something which is called a wavelength. And the wavelength is the distance between, say, two peaks or 2 points that are the same in the wave. And when you change the pitch of the sound, the wavelength of the sound wave changes. Let me show you. So I'm going to make the pitch higher. You will hear this on the loudspeaker. So this is a higher pitch, and you can see that the wavelength has got smaller. Now I'll do a lower pitch, and you see the wavelength is getting longer. The distance between those two peaks gets further. And a very low bass.
Okay, now I want to see if we can go really low or really high. Oh, I can't hear this. Is there still a wave?
Yes, you can see there is still a wave.
Will the same happen if I go very, very high?
Let's see. I need to change the oscilloscope so we can still hear it, see it.
Ooh, my ears really hurt. I think we'll stop here for a minute. Now we're going to see how somebody talking looks like on the oscilloscope.
Okay, so what we're going to see is on the radio picking up somebody who's speaking the weather forecast for airline pilots.
0 degrees. Visibility 10 kilometers or more. Cloud 2 at 1,100 feet. Temperature 21. Dew point 13. QNH 1023. 1230 Zulu, wind 070 degrees, 9 knots. Wind varying between 030 degrees and 090 degrees. Cab OK. Temperature 17. Dew point 8. QNH 1024.
And that was it. I hope you enjoyed this and learned something extra about sound waves.